The idea behind backward chaining in rule-based systems is to start with a goal and work backward to identify the facts needed to prove it. So let's start with the steps for backward chaining. Step 1. Find a matching assertion in the list of assertions. Otherwise, find a matching consequent. If none exists, hypothesis is false. Step 2. Short-circuiting takes place when antecedent or first part of and does not hold. Step 3. Rules and antecedents are tried in the order that they appear. Here are some important symbols you need to know before we work through a backward chaining example by hand. This is how we draw a short circuit when the condition is not satisfied. This is how we draw an AND, where all conditions must be satisfied. Finally, this is how we draw an OR, where only one condition at the very least must be satisfied. Okay, so once again our assertions and rules are the same as our forward chaining video. A0, Hannah likes to sing. A1, Hannah is a celebrity. A2, Zack lives in a hotel. A3, Zack performs on stage. And our rules are P0, if X likes to sing, then X performs on stage. P1, if X is a celebrity and X performs on stage, then X has a fan club. P2, if X has a fan club or X performs on stage, X receives gifts. Now, what if I ask you, does Hannah receive gifts? Here's how you'd use backward chaining to answer this question. First, let's write it as a statement. Hannah receives gifts. Now, according to step 1 of backward chaining, we check if this statement is one of our assertions. It's not, so we're going to find a matching consequent. Looks like P2 matches, so now let's draw an OR. In order for P2 to hold, what must be true? Either Hannah has a fan club or Hannah performs on stage. So we write these conditions down. We had to check these in order, so first let's check if Hannah has a fan club. We don't have that assertion, but it does match with the consequent of P1. In order for Hannah to have a fan club, Hannah must be a celebrity and Hannah performs on stage. So let's draw an AND. Again, let's check these in order. Hannah is a celebrity. That's an assertion. A1, yay! Now let's check if Hannah performs on stage. Remember, since this is an AND, both of these statements must hold true. Hannah performs on stage is not an assertion, but it does match with P0's consequent. In order for Hannah performs on stage to hold true, Hannah likes to sing must hold true. Hannah likes to sing is an assertion. A0, yay! Okay, so if Hannah likes to sing is true, then Hannah performs on stage. So now that we know that Hannah is a celebrity and Hannah performs on stage, so Hannah has a fan club. Now, do we need to prove that Hannah performs on stage? I mean, technically we have already proved that, but we don't even need to look at that second condition because it's an OR statement and we already have proved the first condition to be true. Therefore, we can say yes, Hannah receives gifts. I mean, I don't, but Hannah does. I'm happy for her. No, truly, at least someone loves her enough to give her gifts. Anyway, let's do another quick example. What if I asked you, does Zack receive gifts? At this point, y'all know the drill. There's no matching assertion, but we have a matching consequent with P2. So let's check if either Zack has a fan club or Zack performs on stage. Of course, we do this in order. So for Zack has a fan club to be true, Zack must be a celebrity and Zack performs on stage. Okay, let's check if Zack is a celebrity. It's not an assertion, but there's no matching consequent either, so we must short-circuit it. If Zack is not a celebrity, then Zack doesn't have a fan club. Okay, we should check the second condition. Zack performs on stage. If this also doesn't hold, then that means that Zack doesn't receive gifts. Fortunately, he's luckier than me. Zack performs on stage is an assertion, and thus Zack does receive gifts. Comprende? So this is pretty much it. This is one of the simplest AI models, rule-based systems at work. You can see how rule-based systems are so interpretable. It's easy to understand how the computer is coming up with conclusions. Unfortunately, that won't be the case as we discuss other models in future modules. Congratulations on finishing Module 1. Stay tuned for Module 2 where we'll do a deep dive on machine learning and feature engineering. Want to go deeper into AI? Check out the MehtA Plus certification program. Details in the description. Don't procrastinate.
ME to the HTA plus, that's my zone. Leaping hurdles, breaking boundaries, never alone. Miss Paws on the block.